Okay, this is the Physics of Dropping a Cat by Andrea Boyd, and I'm in section MO1 of Dr. Greco's Physics 2211. So how this video was set up was I had my roommate hold my little cat above the couch, and she dropped him onto a pillow, and we measured the time it took for him to fall, how high up it was, and how long, and the force of gravity as he went downwards. So here's the video. As you can see, no animal cruelty involved. So here this is Tracker I used to analyze the data, and then I put this code into my VPython, into this program, and so initially we had the mass of the cat, which was roughly 6 pounds, or about 2.72 kilograms. And we started with him. She was holding him. We had the x-axis be where the pillow is, the ground, or the 0 coordinate be right here in the middle where the pillow is on the ground. And she was holding him about 7 feet up as she was standing on the couch, and she's roughly 5 feet tall. So he would start off at the y coordinate of 2.295. And I put some initial conditions here. I calculated the pillow acted like a very small spring. So I had the relaxed length being 0.127, or about 5 inches, and the compressed amount was about 2 inches, or 0.071, which is how much the pillow went down when the cat landed on it. The spring constant right here was calculated to be 210 newtons, which was calculated by calculating the force that the cat had when he was going downwards. So 6 pounds, or 2.295 kilograms, dropped at 9.8 as a gravitational constant going downwards, divided by how much it was compressed, so that equals about 210 newtons. So the forces acting on the cat as he was dropped were first and foremost gravity, as he was dropped from a high place, and so we had gravity acting as a force, but then we also had a drag. So that is also calculated in here. I chose a proportionality constant, B equals about 2. He's big, but not a huge object. So here we calculate the drag force and the velocity of the cat as he's going downwards. The next thing that happened in the video, if you saw, was that when he landed on the pillow, it acted as a small spring. So he was bounced upwards. Not very high, but nonetheless, it was a small spring once he contacted the ground. So that was calculated down here in a second while loop. It was in between a certain time interval. After he hit about a second, he was on the ground, and then he bounced upwards again. So I calculated S by L minus L naught, and the spring force, which was, as it was going upward, was the spring constant times S times the L, the compressed spring. So, and then you update the time, and down here we're going to plot this as time versus the velocity of the cat of the y component. So then we're going to print this down here, the final velocity of the cat. We'll see what that is. So we have him going downwards. Okay. And it says that the time is about 2 seconds, and his velocity is negative 3.62, which makes sense in the y component since he is moving downwards. Okay, so some of the physics principles from this video are the momentum principle that was used to calculate in this code. The net force was calculated from the the drag, the air resistance, and the force of gravity, as well as the spring force. And in an Excel sheet, this is the graph. It turned out kind of funny because some of it was not exactly, the x-axis was not exactly 0, as it should have been when he was moving down, because he was obviously turning in midair. And that's all.